All right, let's take a look at number 18 on our practice problems. This, of course, is a modeling problem, and we're going to model it with an equation and then solve the equation to answer the question. So in this problem, we have an electronic pass for a toll road that costs $30. It's a very common thing these days. The toll, when you go through this road, is normally $4, but it's reduced by 30% for people who have purchased the electronic pass. So determine the number of times the road must be used so that the total cost without the pass is the same as the total cost with the pass. Show full support with algebraic equation, define any variables you use. Okay, so notice that each time we cross the toll road, if we don't have the pass, it will be $4. What will it be if we do have the pass, which, by the way, costs $30? Well, it'll be 30%, reduced by 30%, so 30% less than $4. So be careful how we do that. Uh, what is the unknown quantity in this whole problem? Because we're to determine the number of times we're both with or without the electronic pass, the cost would be the same. Well, the determining variable would be the number of times you use the road, right? If we use the road only one time, it would cost $4 without the pass. With the pass, it would be $30 plus whatever that reduced price is. So obviously, if we were just going to do it once, we would not want to buy the pass. But eventually, the reduction in price with the pass, if there was many times we cross the toll road, then that would be the better option. So the variable is indeed the number of times the road must be used. So, um, oh, I got to do number 17. Let me do number 18 and I'll go back to 17. Sorry about that. Started on the wrong one. Let X equal the number of times the road is used. Okay. So the cost without the pass then is just $4 times every time you use the road, right? So 4 times X. So if you use the road, 5 times, X is 5, 4 times 5 would get $20, right? That's what we would pay. Now, what is the toll cost with pass? Well, it's reduced by 30%, right? So what does that mean? Well, that means if I take the $4 and reduce 30% of the $4, 30% of $4, by the way, is $1.20. 0.3 times 4 is 1.2. Okay. So you can do that and get 2.8, or just realize 100% of $4 minus 30% of $4 is 70% of $4. And 70% or 0.7 times 4 is also 2.8. So I hope you understand a reduction of 30% is going to be $2.80. Okay. So that is the reduced price. So what will the cost with the pass be? Well, now we pay $2.80 or 2.8 times the number of times we use the road. So if I use the road 10 times, it'd be 2.8 times 10 or $28. But we also have to add what? The cost of the electronic pass. Okay, so there's the two quantities. Costs are the same when they're both equal. So I set 4x cost with the pass to 2.8x plus 30 cost without the pass and with the pass. And then I just solve. I subtract 2.8x from both sides. 4 minus 2.8 is 1.2. And then divide 30 by 1.2 and I get 25. So the toll road must be used 25 times for costs to be the same. Now, let's go back to number 17. Sorry, I was supposed to start with 17. I started with 18 for some reason. 17 is also a modeling problem. Here we have a new car worth $48,000 is depreciating in value by $3,200 per year. So write a formula that models the car's value Y in dollars after X years. Now, notice they've given us the variables, right? In general, in these problems, you have to clearly state what your variables were, like I did in number 18. But if they give them to you, that's great. So Y is the car's value, X is the number of years. So what will that formula be? It will be this, right? We take 48,000, which is the new car's value initially, depreciating, and it's going down by how much? 32,000 each year. So I would take 3,200, not 32,000, 3,200 each year. So that would be 3,200 times the number of years, where X, of course, is the number of years. So for instance, after 10 years, 3,200 times 10 is 32,000. 48,000 minus 32,000 is 16,000 would be the value of the car, excuse me, after 10 years. Now, in part B, it's just use the formula from part A to determine how many years, after how many years the car's value will be 19,200. So the car's value Y, we're going to let be 19,200, and we're going to solve for X, the number of years. So I've just replaced Y with 19,200. Solving for X, notice I can add 3,200X to both sides of this equation, right? Which will get rid of that, and I'd have 3,200X over here. At the same time, I'm going to subtract 19,200 from both sides. So this is the equivalent equation we get after doing that. Now 48,000 minus 19,200 is 28,800, and then solve for X by dividing by the 3,200, and we get 9. So the answer is, after 9 years, the car's value will be $19,000, $19,200. Okay. Now we got 17 and 18 done. Let's go to number 19. A rectangular swimming pool is 3 times as long as it is wide. If the perimeter is 320 feet, what are the pool's dimensions? And again, define any variables, shows full support. So what's this look like? Again, some of you can solve these problems without writing out the equation. But again, I just submit to you that you are really solving the equation in your head. You have to be able to write that equation down, clearly showing support. That's important. That's what we're trying to get you to understand and learn how to do, so that when the problems become much more difficult, you have that skill. Okay. So the way I'm going to proceed with this problem is, first of all, when we say what are a pool's dimensions, what do we mean? We typically call them the length and the width. Those are the two different side lengths on the rectangle. And the perimeter is the total distance around, right? So notice, since we're told that the swimming pool is 3 times as long as it is wide, basically meaning that what the length will be 3 times the width, right? If it's 3 times as long as it is wide, the length is 3 times whatever that width is. So for me, I'm going to let X then be the width of our swimming pool, of course, measured in feet. Then, as we said, the length of the pool is 3 times as long, so it's 3 times X. Here's my width. Here's my length. Again, since the perimeter rectangle is the sum of what? Go on all the way around. If I have a rectangle, all right, here's the width, length, here's the length. Here's the width, here's the length. So we go length plus width plus length plus width, right? So twice the length and twice its width. We add those up. So some of you remember that formula. So 2 times the width, which is X, plus 2 times the length, which is 3X, equals the total perimeter, which is 320 feet. So here's our equation. So there it is. Now we just said solve it. 2X here. 2 times 3 is 6X. Add 2X to 6X gives me 8X. And then divide 320 by 8 gives me 40. Okay, that must be the width, right? Remember, X was the width. Well, what's the length? Well, it's 3 times whatever X is. So 3 times 40 is 120. So the width of the pool is 40 feet. The length is 120 feet. And just double check that the perimeter is indeed 320 feet, because if I take 2 times 40, that's 80. 2 times 120 is 240. 80 plus 240 is 320. And the length, right, is indeed 3 times the width. So everything in the problem is satisfied. All right, number 20 is a similar problem. Another rectangular area. A rectangular parking lot has a length that is 3 yards greater than the width. The area of the parking lot is 180 square yards. Find the length and the width of the parking lot. Okay, so find those dimensions again, showing full algebraic support with an equation and defining any variables we use. Okay, so in this case, the length is 3 yards greater than the width. So again, what I'm going to do is I'm going to let my variable represent the width. What does it mean that the length is 3 yards greater than the width? It means I add 3 yards to the width, right? 3 yards greater means addition, right? And so in this problem, the width of the parking lot, I'm going to call X. Of course, the measurements are in yards. The length of the parking lot, therefore, will be what? 3 yards more, X plus 3. So X is the width, X plus 3 is the length. Now, the area of a rectangle is what? The product or multiplying, right, the length and the width together. So if I take the width X times the length X plus 3, we get the area. And remember in the problem, we were told that the area of the parking lot is 180 square yards, square units, right? So we get this. And how do we solve this? Well, this is not a linear equation. It's going to be a quadratic equation. I'm going to distribute x through here, right? And I get x squared plus 3x equals 180. Now, how do I solve a quadratic equation? Well, in this case, because we have both the squared term and the linear term, we want to set it equal to 0 by subtracting 180. And then we want to try and factor if we can. That would be the easiest way. You could also use completing the square. You could also use the quadratic formula. In this case, the factoring is pretty easy. I need two numbers whose product is negative 180. That adds to positive 3. That means the two numbers have to be opposite signs since their product is negative. And since the sum is positive 3, the positive one is the bigger one in absolute value. But they're pretty close together, right? Since one is positive, one is negative, and they add to positive 3. They're pretty close together in absolute value. So the two numbers are 15 and negative 12. Those add to positive 3, but if you multiply 15 times negative 12, you get negative 180. And you can use your calculator to help with that factoring. Okay. So when I have factored this and set equal to 0, I use the zero factor principle. In other words, if I have the product of two or more things that equals 0, I know at least one of those things has to be 0. So either x minus 12 is 0, meaning x is 12, of course, if I add 12, or x plus 15 is 0, which means x is negative 15. Well, of these two, obviously the negative 15 makes no sense because x is the width of the parking lot. We cannot have a width that is negative, right? It has to be always positive. So this is the solution for x that we want. So notice x is the width, that's 12 yards. What is the corresponding length? X plus 3. Obviously 12 plus 3, 15. So the length will be, 15 yards and the width will be 12 yards. Okay. And you can check and confirm. If you multiply these together, you indeed get the 180 square yards, which is the area of the parking lot. Okay. All right. Done with the modeling problems. Let's look at 21 and 22. So we're in 21, we're express each interval in set builder notation and graph the interval on the number line. And so for A, notice the interval notation. This bracket means I include negative 3. So the set builder notation, we start with the curly braces for set, write the variable x. This vertical bar basically means given or such that. What's the condition, in other words, for the values x? So it's a set. We say the set of all x such that or given that what? We have negative 3 is less than or equal to x because of the bracket. But what? Less than 9 because the parentheses do not, it's not less than or equal to. If it was less than or equal to, we'd have a bracket. Okay. So on the real number line, the way the book does it, at negative 3, we've got a bracket going this way. And at 9, we have a parentheses, just like we do in the actual interval notation. And then we shade in everything, make a thick line in between those two. You can also use this notation. This is used by other textbooks. Filled in circle means we include it. It's like the bracket. Open circle means we exclude it, like the parentheses. Okay, the next one is from -infinity to 5. So how do we do this? There's no left endpoint, so it's what everything less than or what equal to 5 because of the bracket. So I have set of all x such that x is just less than or equal to 5. And how would I do that? Well, I have a bracket at 5, or you can do a filled in circle. And then I shade in everything to the left. I keep going forever. Since I can't keep going forever, just draw a little, thick arrowhead showing that direction. Okay. In 22, we have some inequalities to solve. So let's look at this first one. How do I solve this inequality? Well, we solve it basically, this is a linear inequality, so we solve it just like we would a linear equation. The one thing we got to be careful with is if we multiply or divide by a negative number, we have to change the direction of the inequality. This one here has a lot of fractions in it. What I want to do is I want to multiply by the least common denominator to get rid of those fractions. That makes it easier. You can work with just the fractions, and that's fine. But I'm going to do it this way to make life a little bit easier. And our denominators are 10, 5, I guess 1 divided by 1 here, so 1. So the least common denominator, hopefully everyone sees, is 10. So I'm going to multiply everything by 10. So this side I'm going to multiply by 10, and this side I'm going to multiply by 10. And I distribute that through, right? So 10 times 3x over 10 plus 10 times 1. Same thing here. 10 times 1/5, 10 times x over 10. Now I simplify. Here, right, 10 divided by 10 is 1. I'm just left with 3x. 10 times 1 is 10. 10 times 1/5 is the same as 10 divided by 5, which is 2. Here, 10 divided by 10 is 1. I'm just left with x. So now I've got rid of all those fractions, and this is much easier, right? So what can I do? I want to get all my x's on one side. And typically with inequalities, we like to do it on the left side if we can. So I'm going to add x to this side, all right? And I'm going to subtract 10 from both sides. Add x to both sides and subtract 10 from both sides. So I get here. Now combine like terms. 3x plus x is 4x. 2 minus 10 is -8. To solve for x, I divide by 4. Since I'm dividing by a positive number, the direction of the inequality does not change, and -8 divided by 4 is -2. So my solution is all values of x greater than or equal to -2, and we write that in interval notation. So everything greater than or equal to -2, the left endpoint is -2, which I include, bracket. There is no right endpoint, so I use this infinity symbol, and we always have a parentheses there. Okay, 22b has a compound inequality. So what's that look like? Well, basically we're going to isolate x in the middle here, and we are going to do that by first adding 7 to all three quantities. I add it to the 3, I add it here, and I add it here. As long as I do the same to all three, the inequalities remain equivalent. So obviously 3 plus 7 is 10. Here the 7 disappears to 2x. Here 8 plus 7 is 15. And now to solve for x, I'm going to divide everything by 2. So all the quantities get divided by 2. Again, since I'm dividing by a positive 2, the inequalities do not change direction. And so I get 5 is less than x is less than or equal to 15/2. So I've got left endpoint 5, parentheses, because it's less than or equal to 15/2, right endpoint, bracket, because it's less than or equal to. There's the interval notation. All right. C has a absolute value inequality. It says the absolute value of 3x plus 5 is less than 14. Keep in mind, in general, if I have the absolute value, I'm just going to say of a, some expression, is less than some number like 14, of course, some positive number, then what is this really saying? The absolute value of a is the distance a is from 0. So in that case, if we're less than 14 units from 0, we must be between negative 14 and positive 14, right? The value of A must be between that interval. So that's how we set up these inequalities. Whatever's inside here is between negative 14 and positive 14, okay? So to isolate again, this is just like the one I just did. I'm going to get x by itself here. I'm going to subtract 5 from everything. Negative 14 minus 5 is negative 19. Then here I have 3x. 14 minus 5 is 9. And then I'm going to divide by 3. Again, dividing by a positive number does not change the direction of the inequalities. And I get the following, right? And so notice it's less than and less than. So I've got parentheses on both of these endpoints. And this is the solution. So and basically we're saying any value of x between negative 19 thirds and 3 will make this statement true. And you could check again, like if I plug in 3, which it shouldn't work, notice that's kind of the borderline, because if I plug in 3, I get 3 times 3, 9, plus 5 is 14. The absolute value of 14 is 14. Well, 14 is not less than 14. So that's sort of the borderline. If I plug in something a little bit less than 3, but greater than negative 19 thirds, then this will work. All right, the last one is this inequality here. The first thing here to note is I want to get the absolute value expression, the absolute value of 2x minus 1. I want to get that by itself. So this negative 5, I need to add 5 to both sides of this inequality. And adding 5 to 4 gives me 9, and that isolates that inequality. Now, this one has the absolute value of some quantity being greater than or equal to a number. Well, in this case, the number is 9. So what's that mean? Your distance from 0, you're more than or equal to 9 units from 0. So you're 9 or more units from 0. So what's that mean? Well, that means either A is greater than or equal to 9, right? Because that would be more than 9 units from 0. But also A can be less than or equal to negative 9, right? Going in the other direction. And so we end up in this case with 2 different inequalities to solve. Okay? So that's what I've done. 2x minus 1 is either less than or equal to negative 9, or 2x minus 1 is greater than or equal to 9. And I solve each one separately. Here I add 1 to both sides. Negative 9 plus 1, be careful, is negative 8. Divide both sides by 2. Doesn't change the direction of the inequality. I get x is less than negative 4. Over here, 2x minus 1, I add 1 to 9, I get 10. Divide by 2, I get x is greater than or equal to 5. So I want to write these in interval notation. X less than or equal to negative 4 is written this way. X greater than or equal to 5 is written this way. And then what's this symbol? This is the union symbol. Union, or we say or sometimes. So when you have distinct intervals that don't overlap, we will usually use that notation. That's from set notation. Okay, so hope all these things help. Let me make sure I've completed all my questions. And sorry for starting on the wrong one. Okay, hope this helps. If there's any questions, let me know.